everyone, we're going to work on the Unit 9 end of unit assessment. So we're going to be talking about exponents in the number system. So the first question says, use a single exponent to write the expression with the same value. So I see the quotient power here, so that tells me I have to subtract my exponents. So I'm going to do 8 minus negative 1, keep, change. So I get 5 to the 9th power. This is the product property, so I'm going to add my exponents. 3 plus negative 1. So I have a positive 2. So it's going to be 4 to the 2nd power. Circle all the true statements. So this is the product property, so I'm going to add those. So that would be x to the 1st power. This is the product property again, so this would be x to the 3rd power. So that one's true. This one would be the product property. So again, I'm going to add these. So that would be x to the 5th power. All right, these two are equivalent because anything to the negative exponent becomes a fraction. I'm going to subtract these two, so 8 minus 2 is x to the 6th power. All right, right as a single exponent, so I have to add those two, so I get x to the 11th power, which expression is equivalent to 4 to the 2nd power. So anything to the 0 power is 1. This is the product property, so I'm going to add 4 to the 8th. This is power of a power, so I'm going to multiply. So I end up with 4 to the 2nd power. This one is 4 minus negative 2. Keep, change. I end up with 4 to the 6th power. All right, write the following as a power. So I have 1, 2, 3, 4 sixes. So that means it's 6 to the 4th power. Number 7. Okay, that would mean that I am working inside my parentheses. So 1 plus negative 2 is going to give me 5 to the negative 1. And then I have to the 0 power. Anything to the 0 power is 1. They want us to choose all the perfect squares. So I can get that off of my multiplication chart by looking at all the yellow highlights. 144, 64, and 1. Those are all my perfect squares. All right, write an equivalent fraction. All right, I have two numbers underneath my repeating bar. So if you remember, we start with x equals 0.08, repeating, and then we're going to multiply each side by 100. Because the goal here is to get rid of the repeating part. So you have 100x equals 8 and 8/100ths repeating. So then I'm going to go back and I'm going to subtract this part right here off so I can subtract off the repeating part. So I'm going to subtract x and I'm going to subtract 0.08 repeating. I end up with 99x and I end up with that equals 8. So then I'm going to, now I have a one-step equation. So I'm going to divide both sides by 99. So x equals 8 divided by 99. All right, which number is an irrational number? So they want the irrational number, so we're looking for pi or a non-perfect square or a decimal with no pattern. So a fraction is a rational number, a terminating decimal is a rational number, and this is a perfect square, so that's a rational number. So C is the irrational number. For this one, they want to know which integers, when placed in the box, shown below will make this inequality true. So we've got negative 70. We've got the square root of negative 70. So if I'm trying to think of my perfect squares, I know that I have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. And I know that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 70 is going to fall right here between these two. And I'm going to so it's going to have to be two negative numbers, right? So I know it can't be A or B. And it's going to have to be 8 and 9. Because those are the two perfect squares it fits between. All right, which is a rational number? So this one is irrational because there's no pattern. This one is rational because it's a repeating decimal. This is irrational because it has pi. And this one is irrational because it's a non-perfect square. So B is the correct answer. They want us to write an equivalent fraction. So I start with x equals 0.48, repeating. I'm going to multiply each side by 100. So I have 100x equals equals 48.48, repeating. Then I go back and I subtract off the repeating part. Which leaves me with 99x and 48. Then I have a one-step equation, so I'm just going to divide by 99 on each side to get the x by itself. So x equals 48 divided by 99. All right, the next one is what is the value of the square root of 7 to the nearest tenth? So I've got 1, 4, 9. So I know that my perfect square is going to fall right here between these two. So I do 7 minus 4 divided by 9 minus 4. So that leaves me with 3 divided by 5. So 3 divided by 5. Decimal point to 0. 5 goes into 36 times. So I end up with 6/10. And then I have to choose the number with the smaller, I have to choose the perfect square with the smaller number, so it should be 2.6. All right, next one. So they want to know what's the best description of this number. So let's see if we can figure it out. So the cube root of 27, so what number is times itself? So 1 times 1 times 1 is going to be 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So we got 3. 12 divided by 3 is 4. So that's a whole number, right? So we know it's not irrational. And yes, it could be an integer. Yes, it could be a rational number. But the best description of it is a natural number, because that's the innermost circle of it. All right, what kind of number is 3/100 repeating? So again, this is a decimal. We know it's not irrational because it can be changed into a fraction. And it's a decimal, so it can't be either of these. It has to be a rational number. based on the fact that the square root of 81 is 9 and the square root of 100 is 10, which of the following options would be the best approximation for the square root of 90? Well, if I know that 90 fits between the square root of 9 and 10, right? Because I've got 81 on this side, 100 on this side, and that's 9, and this is 10. I would take a whole number of 9, and then it would be some decimal point. The only option is D. All right, which of the following points could this represent? Well, the square root of 23, it's not going to be a negative number. And if I'm listing out my perfect squares, it's 1, 2, 3, 4, 5. It's closest to 5, but not quite at 5. So the best option is K. All right, a set of numbers is given and they want it listed from least to greatest. So we have to put these numbers in order from least to greatest. So we know that pi squared is going to be about 3.14 squared. So that's somewhere around 9. We know this one's 6.5. We know this one's 10.4. Okay, square root of 18. So we list out our perfect squares. So that would be 1, 4, 9, 16, 25. So 18 is going to fall in here. So it's going to be 4 point something. And then 6 is 36. So it's going to be 5 point something. So if I was going to put these in order from least to greatest, I know I have to start with the square root of 18. Then I would have the square root of 35. Then I would have 6.5, pi squared, and then 10.4. So my answer is B. So I don't actually have to figure them all out. I have to get an estimation. And then the last one, which choice is both the square of an integer and the cube of an integer? So you're going to have your multiplication chart available to you. So you'll be able to look. But your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. And then your perfect cubes are 1, 8, 27, 64, 125, 216, 343, 4, 5, 6, 7, 512, 729, and 1,000. So 121 is not on both lists. 27 isn't on both lists. 25 isn't on both lists, but 1 is. All right? Let me know if you have any questions. I know you're going to do great tomorrow. Have a great rest of your day. Bye.